Okay, so now we have a talk from Julien and Lozi about SCExAO and all its fascinating aspects.
Thank you. Yeah, so I'm going to talk about all the shiny things that that Bruce mentioned that we have on SCExAO and the extension AO3K. So first, I'm going to do a quick land acknowledgement. So we work on Mauna Kea. Mauna Kea is a mountain that connects the Kanaka Maoli to their ancestral and universal origins, and we as scientists and educators, we acknowledge this interconnectedness between Kanaka and the Aina, and we recognize that we have a kuleana that comes with the opportunity to pursue astronomical research on Mauna Kea. And it is our kuleana to build and strengthen healthy relationships with the land and the people of this place based on mutuality and trust. So let's go back a few years ago. Spirit of Leo, there was this young guy that had an idea. Maybe we should build an experimental platform that's also doing science in the spirit of Leo, and what could go wrong. And actually, if you go online, the website is still live. There's still the slides of everyone. It's pretty crazy. And so I found this slide from Olivier with the little SCExAO in the middle, not quite SCExAO yet. Very simple design, and it became this monster. So this is all the versions. We hear about GPI 2, Sphere Plus, Axo Plus. That's cute, but for us, we're more like software upgrades. We have versions, and sometimes some versions break, and we have to make a patch to solve it. So a quick overview. So SCExAO, as I said, is at the same time a test bed and an instrument. So we test during the day. We are an instrument doing science at night. We do some tests at night as well, of course. We work at the Subaru telescope, Mauna Kea. We have about 50 nights per year, about more than 40 of science every year. And we began in 2009. But we started first flight in 2011, first science operation in 2014 with Haichao, then with Caris in 2017, and Vampires in 2018. And we're testing a lot of things. As you know, we're testing wavefront control, chronography, imaging, interferometry, spectroscopy, polarimetry, and photonics. So yes, we are a science instrument. We saw actually some great talks, talked by Thane, but also we have a bunch of posters. These are just in the last year. So all the people listed here are at this conference, so talk to them. And these are a few discs that we heard about as well. And in bonus, we have also these people that have posters at this conference that are regular observers. So yeah, please talk to them about their experience. So what happened since the last Spirit of Leo? SCExAO went from version 3.14 to version 3.21, and AO188 became AO3K. I'm not quite sure about the versions. I try to do that quickly, but anyway. So the first I'm going to talk about is really AO3K. That was the big upgrade that we did in the last few years. We upgraded the facility adaptive optics AO188. And so the first phase was to add a few things. So in regular operation, we have either SCExAO or IRCS behind the facility AO, and we have to crane them in and out depending on who's observing. We updated the AO with a near-infrared wavefront sensor. We replaced the DM with an ARPAO 64x64, and then we also added a nonlinear visible curvature wavefront sensor and a polychromatic calibration source to test all that during the day. And so this is a view of the new DM inside the instrument. This is a video from Maria Vincent, who also has a poster about the Keck DM that's very similar to this one. These are zygo measurements with the logo applied on it and Olivier's face. And then we have the rack of electronics. So I'm glad the new DM for ESO is not going to have this giant stack of electronics, but it will be included in the DM itself. So this is one of the first light on sky of the system with SCExAO running as well. So we had two Extreme AO at the same time. we have the near-infrared wavefront sensor at the top, SCExAO's visible wavefront sensor at the bottom, and then some infrared images without and with coronagraph, and the DM command on the DM3K. And everything worked really well. We're also lucky to have excellent seeing on the commissioning of this, but this system has been operated for science since then and gave us very great results. The PSFs are beautiful. They are so similar to the simulations. It's a little scary. And we had a very good tip-tier control to the roughly 3 milliardsecond. And this is in visible with vampires. We also had very good PSFs. We got some trails up to 60%. And this is to demonstrate that AO3K is already providing very good PSFs without SCExAO behind. On the left is AO3K only. On the right is AO3K plus SCExAO. We do have some static aberrations that we're not correcting well. We need a better calibration of the flatness of the DM, of both DMs, to do a better job, but it's already very good. We tested the nonlinear curvature on Sky, but we had some computer limitation at the time. Olivier is actually at the summit this week working on a new computer with better CPU and GPU. So if you wonder why he's not here, that's why. And so we managed to close the loop. The straw was not impressive at that time, but because we had all these issues with computer. In phase 2, that was this year, or last year, I should say, things got a little complicated. We added a NASBIS beam switcher, so just some relay optic that allowed to have a bunch of instruments that can use the AO3K during the same night or same run. We moved the near-infrared wavefront sensor outside of the instrument to allow it to have some upgrades and a little bit more room. And it's on a platform next to a new LTO system, Ultimate Start, that's going to go on Sky very soon. And we also have some an extra port from the MBS, where Spiders was tested. Sorry if I freaked you out with the logo. And there's a lot of talks and posters about Spiders. They only got a few test nights recently, but it was very successful, and I'm very grateful for them to have done all this work, because it showed us that with AO3K we can start doing speckle control, digging dark holes dynamically on Sky with AO3K, with the SCExAO DM, and we should also use machine learning for our low-order wavefront sensor. This is the NASBIS beam switcher when we were aligning it, and over there is the CAD view of the whole system, and on the bottom is a camera view of what it became, so it's exactly the same, and then very good wavefront error from the system at all the ports, so we're very happy about that. The NBS is working very well. And this is the latest picture with Spiders behind as well, so all the components are now here. The NASBIS platform is getting very full. Version 2 of near-infrared wavefront sensor, we had, I added a few modes, so sorry, this is my baby. I've been working on this since COVID. And basically, we added optical beading mode, where the pupils are 2 times smaller, but that allows you to reach fainter targets. We also added a field stop and a near-infrared acquisition camera to be more efficient on Sky when we want to lock on a target. The issue we still have is low wind effect. Subaru is pretty bad for that because of our very thick spiders. We think it's affecting us about 30% of the time. We even had times where like half of the data was unusable because of this. So you can see top and bottom, these are multiple star system, and sometimes it's good, sometimes PSFs are splitting because of this. This is very annoying. We're trying to figure out what to do. We have a lot of ideas, a lot of people are working on different things. We have Gary Massing is back now in the team to work on the YOFIS. We have the Fast and Furious, Too Fast, Too Furious. We have Sam Walker that has a poster. For example, Lucy worked on a apodizing mask called RAP. She technically is supposed to have a poster, but she's not here, so there's no poster. Sorry. But it worked very well. So the conclusion is that there's not a unique solution to fix that. There's depending on the observing mode, we have different ideas. So SCExAO was represented like this, but in reality it's more like this. There's a little bit more than what I showed. But basically in the last few years, what we did was upgrade the vampires. We have Miles somewhere here that did most of the work during his PhD and to upgrade vampires. We have a new photonic lantern mode invisible called First PL. We have Yu Zhang that's going to talk about it tomorrow. It is actually now offered for science. And then a CIRED1 spectroscopy using photonic lantern and using glint, which is a nuller with some PIC, infrared photonic lantern. And then we have K-Reach, which is a signal mode fiber injection in K-band that sends light to the IRCS spectrograph. And finally, MEC. Now MEC Prime is being upgraded at UCSB. And so, as I said, we have a talk by Yu Zhang tomorrow. You really need to watch that. And First PL is now offered for science. Call for proposal is open. Let us know if you want to submit a proposal. But yeah, there's plenty of things to do with us. MEC Prime has 2 posters. Invite you to see those, and also to watch their YouTube channel. This is, I think, the famous YouTuber Ben Mazin is in the room right now. And I'm going to go quickly over the infrared spectrograph. This is my second baby that I built for the CIRED1 camera. It's extremely compact. It's about this size. And it's a photonic spectrograph where we can test a bunch of photonic technologies for glint, for the photonic lanterns, etc. And an example is this. We have some students in Australia that worked on this. And basically, we tested the tricoupler technology. We created some null channels. And with the bright channels, they could close the loop and stabilize the null. Mona has a poster about some PIC developments in the continuation of this. And my final slide, next steps, what happened for SCExAO v4. We want to improve wavefront control, since AOCK is giving us a nice PSF. Thanks to spiders, we have some ideas on what to do next. But also, we're going to replace our 2K DM to a 3K segmented DM by the end of the year, because we want more actuators, but also a DM like this could help us with testing TMT and HWO technologies. And since we end up with a free 2K DM but no electronics, maybe we want to buy a new set of electronics, those are cheap from BMC, and replace Ford mirror with the new with the old 2K DM to create a 2DM control. And then maybe upgrade of Caris V2. We have now new detectors that are very promising. There's actually a poster, so I didn't write it, by Guillaume about the testing of the 1K by 1K from Leonardo. And hopefully in the very near future, we'll have a 2K by 2K that could be a drop-in replacement for Hawaii 2RGs, and everyone should jump on those. And that's it. Thank you.
We have time for one question from Julien.
Thank you. Great, awesome. Do you think this kind of segmented DM could help break or smooth out the differential Pilston that you have in low-wind effect and maybe get rid of it?
It is possible, so that's one of the things we want to test. Yeah, that's possible. The spiders are not necessarily going to align very well with the segments, but we'll see how it works.